Hello again, this is Keith Davis at KLJ Instruments. At the conclusion of the previous video, we had created a WAM scenario with 4 Mode S surface targets. Each surface target is parked at the location of one of our ground stations so that we have an aircraft symbol for each one of the radar cape map display. I will select WAM mode from the main menu. Now I want to browse the directory to load the GUI file that I created last time. I will load the W4 fixed targets file as a starting point. Now I want to add my moving target. I will use target 0 and give it a Mode S address of 00000F and a flight ID of KLJ0. Waypoint 0 is at time 0. I will set waypoint 0 at a latitude of 38.887 degrees, longitude of negative 94.845 degrees. I will make the target airborne and enable the airborne squitters. An altitude of 5,000 feet. Because the radar cape uses the velocity vector to determine the heading of its airplane symbol, I am entering 50 knots for the east-west velocity and negative 550 knots as the north-south velocity. An important point to note is that this velocity data is inserted into the appropriate fields of the airborne velocity splitter, but this data does not control the actual velocity of the simulated target. The velocity of the simulated target is controlled strictly by the position and the time of the waypoints. I will set the time for waypoint 1 to be 12 seconds. Next I will program waypoint 1 at 38.868 degrees latitude, negative 94.840 degrees longitude, and 4,000 feet altitude. Once all 6 waypoints are programmed, I can review my data. Now I am ready to enable target 0 by clicking the Enable Mode S Targets 0 through 99 button, checking all 6 waypoints, and accepting the changes. I will compile this scenario and save it with the file name W, 1 moving and 4 fixed targets. We are now ready to run this scenario and view our moving target on the radar cape display. The radar cape does not smooth the target track, so the target jumps from one location to the next. However, you can see that our target is following the path shown in the map. Now I want to look at the relative squitter timing on the oscilloscope. This timing is controlled by the TDOA simulation. First, I will declutter the display by removing the surface targets so that only the moving target is displayed. I now compile, then save this scenario as W, 1 moving, 0 fixed targets. Compile, then save this scenario as W, 1 moving, 0 fixed target. The 4 oscilloscope channels show the detected video from the MLAT1 through MLAT4 channels. Note how the relative timing changes as the scenario runs and the target gets closer to and then farther away from individual ground stations. Thank you for watching this video demonstrating how to program a WAM moving target. In the next video, I will demonstrate how to extend the path of the target by adding more waypoints.